Hi, welcome to the third video. So the objective of this video is trying to generate a function that can help us to simulate or just to give like the periodic Gaussian decay heat flux in ANSYS simulation. And here I opened up a function called generate function, and I'll give this MATLAB to you as an appendix. So here, basically what the function does is just to help us to generate this function. So the template is given over here, and I'll tell you where it comes from. So we have like R is the spot size, which is 3 over here, and omega is the frequency, is 2 pi frequency, the angular frequency. And we have a power as 1 milliwatts. And here is just I combine the power with the periodic density, which is sine omega t. And the power is just adding another part of the Gaussian decay. And now we run this. So we got this like outrageous function, but don't worry about it. It's not that complicated because it's just, I don't know why it just can't be divided out. So if you can help with this part, just make everything more smoother. And now we just copy, paste, and copy this part. Basically what we're doing here is just to organize everything. And to run that, you got this value, you copy, and let's just type 70736. And inside of this sign, you don't have to change anything. So here I have frequency. Here I have like 10 to the 5. This is just 1e5 hertz as we normally use in the FDTR. And time is just time. And then it's the exponential. And in the exponential, you just only need to do one thing, use this value, paste, and divided by this value. Now you have this 2.2222. 2.22. Oh, let's just save it to the last 2 digits. Okay, so here's something else that we need to do. You need to search here APDL. So APDL is like, I think it's the base structure of ANSYS simulation, like, and it's called like ANSYS, some program language. It's just like it has more functions, but it's more difficult to use. But we don't have to worry about that because what we want to do is easy. We just click parameter function, define and read. Okay, over here, you look for your MATLAB, and you copy this, copy, and can I paste? Why I cannot paste? Oh, because I have my caps lock on, so now we can paste it. And you just need to click file and save. You can save it. I'll just save it. Okay, over here. How should we call it? But it's better just like call it using like the spot size and the frequency we are using. So we have 3 that hyphen and the frequency 1e5. Okay, save. And now we click this quit. Okay. So for this part, from this part, we just like unsuccessfully generated the data, but how can we use it? Now I want to insert something. It's called insert command. And I will open up this file. I'll also give you this file. You just need to copy and paste. It took me a long time to figure this out. Copy. Paste. Okay, and this is the part that we want to insert. Oh, sorry. This is the part where we select the nodes. That is the nodes as the output region. And this is the part we give the heat flux. And here is just means apply this heat flux to the named selection. And you remember our name selection is called bottom serve. But if we open up the file, we just have you can see that this is the part we don't care about. You can just delete it. And it's different because we have a function name over here. It's called heat flux, but we don't have it over here. So we want to copy heat flux. Sorry, copy heat flux. And Command H. Oh, it's not working here. Control H. All right. I don't know how to replace all. Let me just, okay, replace. Copy, paste, replace that with this name. Copy, paste, paste. And on the top, we also need to now just check. Looks okay. Here, press 0. And then we copy all of them. Copy. And paste. Now we have our time frequency dependent periodic Gaussianly decay heat flux ready. Oh, yes, we can save that. Okay, what's next? Okay, we finished this part. And for the solution, we insert another comment line. That is comment line 2. This is like post-processing, and what this part does is just help us to output all the temperature. And we can also read it like as, so it's writing as like put the time in the array and puts the temperature in the array. So it's just like array for each node. But before everything, here's something we need to do. Like for this command line, we need to select nodes on the so we don't know what is the nodes on the heat spot. So before we get to run along simulation, we click this insert temperature. So I will, before run such a long simulation, we run a short one, just one time step, you see that? And we suppress this because for now we don't want to get the temperature and solve. This is gonna be fast. The model has no temperature. Don't worry, we have temperature. Oh, this is beautiful. Can you see that? We have this Gaussian decay temperature. And you can export text file, and we can export it to tutorial. Let's say output, save. And then let's go to output tutorial. It's the node is from 172 to 1491. Okay, we'll go back here and 172 1491. Now we have to we can run a longer like simulation, and before that, here's something that we need to do. Something else we need to do. First is just change the time step back. 5E. And remember, we have like 2000 data over here, so like I'm also okay. This is fine. Don't worry, forget it. Something that we need to do is this CF open, because we want to write file, and this is the file on my old computer. And on this computer, let's just write the file over here. We call it like tutorial. Copy. And paste. Now I'll stop the video from here and just run the simulation myself, and I'll see you in the next video.